All right. All right. So I'm sorry I erased it, but I wanted to make one more comment about the interquartile range because it came up. Like one of the reasons for the interquartile range, right, is again outliers. Outliers can affect the range very drastically, and if you can remember, right, that one set of scores, when I changed the last score to 200, the range went from 18 to 198 just because of that one score. So if you have outliers like that, the interquartile range gives you a better representation of the actual range. And so that's one of the reasons for that we compute that sometimes, okay? So I just wanted to add that. And now, the moment you've all been waiting for, I know you've just been dying to really start doing some math. And we have come to that point. All right, so we are going to start tonight with standard deviation. We're going to start with the simple standard deviation. And what that means is the deviation of your score or any raw score from the mean. Right? So we figure out the average, figure out the mean, and that will tell us we're going to start looking at the deviation. Because if you just have your raw score, it really doesn't tell you much. But if we start looking at the standard deviation, what it starts telling you and telling us is where you are in relation to the pack, right? Like remember we talked about percentile rank. It'll help us, we'll learn about where you are in that percentage of people and what your percentile rank would be. We'll demonstrate this and it'll go on as we do. But basically the standard deviation is how far any score is from the mean, okay? So we're going to start with this first very simple formula. I want you to know, and I get this, there are a number of formulas for standard deviation depending on what we are looking at. So be very careful and try to pay attention to what I say or what the questions ask in your worksheet or your exams. Because it never fails that I get an exam back where people start mixing the formulas. And they do half of one formula and they add half of another from two different standard deviation formulas and get way out of whack. So yes, believe me, it happens. I know it sounds unusual, but we're going to start with this very simple one, okay? And basically this is telling us the deviation between the score and the mean. So in this case, we're only going to give you the mean. Right? And here the mean is equal to 13.00, right? So what we do for this particular formula is we take the score and we subtract the mean, and that's the deviation, right? That's the difference, deviation difference. That's the difference between the score and the mean, right? So 10 minus the 13.00 is negative 3.00, right? 11 minus 13.00, negative 2. And this is all what we do. We take whatever the raw score was, subtract the mean. Then we went over here and we squared the result, right? So the negative 3 squared is 9, negative 2 is 4, negative 2 is 4, and on and on. And then we summed the squares. And we got the sum of the squares. This is represented by the small x versus the big X for the raw score, okay? So this is how our table looks for using this formula for the standard deviation, right? And here's our actual formula for the standard deviation, right? Standard deviation is the square root of the sum of x squared over n, right? So here we are, we did all of this to compute this and come up with our sum of the squares, right? So here we are, s is equal to the square root of 54.00 over n, which in our case is 1, 2, 3, 4, 5, 6. to the square root of 9, right? Which is equal to 3, if I'm not mistaken.
Yeah.
Okay? So, this is our very first simple formula, right? For calculating the standard deviation. All right? Now, when I was saying this tells us how far somebody is from the mean, right? We're going to start looking and we're going to go back to that curve. So I'm going to erase this and draw up another, the norm curve, right? I kept saying we're going to be using this a lot. All right? This is our thing. So, the reason this is a theoretical model, right? And remember I said right here, mean, median, and mode. All the measures of central tendency are right in the middle. It's a symmetrical curve. It's a symmetrical curve. This is exactly the same as that. This is 50% of whatever we're doing. This is 50% of whatever we're doing. Okay? All right? So, if we did this, if we went back and did all this and everybody had the same score, this would end up being 0, right? So, anyway, take my word for it.
I was like,
walk
you
through
gonna,
it.
you
All
gonna
right?
show me that?
Anyway, so what I want to tell you here is we're going to start breaking this up and using this model to demonstrate some things. So let's just say right here, this is one standard deviation. From here to here, one standard deviation. And when I say that, what I mean is one deviation includes one side, both sides of the median. So the negative side and the positive side. This entire thing, when I'm saying that. Right? And here is your first rule. We like rules. Remember I said math is easy because of the rules. So here's the rule, right? 68% of your cases, 68% of your scores, 68% of your people, subjects, whatever it is going to lie within one standard deviation of the mean. Right? So this is what we mean. The average person, right? We said, this is the curve that will occur if you studied everybody on the planet. This would be the curve you would get if my population was every college student, and I actually got information from every college student. Theoretically, we say this is the curve that will happen. Of course, we don't study populations necessarily, but we'll get into that a little bit later. However, this is the theoretical model again, and so here is just the rule. 68% of the people taking a test, doing whatever it is they're doing, their scores are going to lie within one standard deviation of the mean. So, let's say I gave you a test.
Is there a reason for that?
It's the rule.
It's just,
yes,
just
it's
because
the
it's the
theoretical
rule?
model,
Oh.
right? So there is a reason for it. You need to do a much different class to understand the reason and get that.
I know.
And if all in here you want to become mathematicians, be happy to do that. However, for this such of purposes, it's just a rule. And I was thinking about this, like, it's the rule that you drive on the right side of the road. You don't have to drive on the right side of the road, but if you don't, you're going to have problems, right? So the same thing. Why do we ride on the right side of the road when other people ride on the left? Who knows?
So,
but that's the way it is.
Someone just
and you
made up that
accept
number?
it, right? That's the way we did it. That's how you accept it. So you're better off just accepting the rule and going with it. Okay? After all hundreds of years, you're not going to change it. Basic, probably. Okay? So, that's the thing about rules. You can take them or leave them. They're just rules. But when you don't follow them, typically things don't work out. Okay? Anyway, so let's just say the mean, I gave a test, and you could get a score from 1 to 100. And the mean actually turned out being 70, right? So this is the mean, is 70. And I did all this, and I did whatever scores, as many people as I got, whatever it is, and I'm going to tell you my standard deviation was 10. Right? So what does this mean? When I look here, right? So the mean is 70. Right? That's what that means. Right? Now, one standard deviation, if you have standard deviation of 1, right, then this is 70, and this would be 80. I'm going to add on the positive side of the curve, and I'm going to subtract the standard deviation, what that amount, on the negative side of the curve. So this is going to be 60. Right? Does that make sense, I hope? Okay. So what I'm telling you now is if I gave it to 100 people, the test was given to 100 people to try to keep the number simple, 68 of the people scored between 60 and 80. 68%, or 68 out of the 100, had a score between 60 and 80. That's what the average person will get. So, the other part of this, right? If this is 68%, right? Mm-hmm. Then this is what? 34%. Right? Mm-hmm. Each side, half then, is 34%. Right? So, if I was to say to you right now, how many people, what percentage of people scored below 80? Right? If I ask you that question now, you're like, wait a second. But it's simple, right? We know right here is 50% of the people. Right? This half is 50%, and now I have 34 more percent. Right? So 84% of the people scored 80 or below. So if you got a score of 80, you're in the 84 percentile. Going back to the percentile rank. Right? It's clear as mud, right?
Yeah.
Again. But we're going to show you how to break this up, and we're going to be able to just establish how many people and what percentage of your subjects, etc., do, where they land, right? Using this standard deviation, that's what I said. It tells you where you are compared to the mean, right? And so, no matter what your score is, these are nice round numbers, of course, but whatever the score ended up in being, you would be able to figure out where you are along this line. And that means where are you according to the mean, right? Most of us want to be above average. Right? Most of us want to be on this side. But, you know, being just on this, just shy of this side is not the end of the world. Okay? And now, the next surprise comes. So this is one standard deviation, right? We divide it up again. And now we have two standard deviations from the means. Whatever the score is, the number doesn't matter, right? Whatever that number is. Like here I said 10, it could be 5, it could be 8.6, it could be any number possible, okay? But at two S point Ds, what I'm going to tell you is approximately 95% of your subjects will score within two standard deviations of the mean. So in this case, using the same mean and standard deviation, right, this would be now minus 10 for 1. So for 2, I subtract 2 times the standard deviation, or 20, and this is 50. Conversely, I add 2, and this becomes 90. So 95% of the people scored between a 50 and a 90 on this exam. On this particular exam, right? Rule number 2. Approximately 95% of your people score within 2 standard deviations of the mean. That's the rule. Okay? Now, this is the one more. 3 standard deviations from the mean.
Is that a 3 SD?
Standard deviation.
Oh, it looks okay.
SD is standard deviation. Up here for this part,
I thought you were writing-
For the most part, you're going to see it like that.
5.
Okay.
Okay.
So, 3 standard deviations from the mean, and the next rule is 99.7% of the people score within 3 standard deviations of the mean, right? So, what is it? We labeled these people out here before. The outliers, that other 3% of the people. Same thing. Conversely, 3 standard deviations from 70. 3 times 10 is 30. From 70 minus 30, this is 40. And this is 100, so nobody got more than 100. All right? So there we go. With this particular mean, 99.7% of the people, so actually in this case, all the outliers are on the low end. But don't worry about that part, right? But 99.7% of your people scored within 3 standard deviations of the mean. Okay? So, those are your rules. 68% of the people score approximately 68% of the people score within 1 standard deviation of the mean. Approximately 95% of the people score within 2 standard deviations of the mean. And 99.7% of the people score within 3 standard deviations of the mean. And this model always works the same. Whatever the numbers are irrelevant. It's about your standard deviations, 1, 2, 3. Whether they're on the negative side or the positive side. Okay? Here's the rule. For the 68% rule, right? Your multiplier is 1. And we'll get into this more. We're going to get into this, but I want you to remember this now. For the 95% rule, your multiplier is 2. And for the 99.7% rule, your multiplier is 3. Keep that in mind. Keep a record of that, however you want to do it, because we're going to, you're going to come back to that and use it again, and there'll be actually one more. Right. So the multipliers are because whatever your standard deviation is, right, when you know the mean, when you have your model, right, and I want to know whatever this score is, right, and I want to know, all right, well, let me do this. Let's do it this way. Make it simple. So we'll stick with the 70. This is how it works. If I want to know where 68% of the people's scores lie, right? Say my standard deviation in this case is 5, right? If I don't want to, and I just want to lay this out, I multiply, if I want to know where the 68% is, right? If I want to know what 1 standard deviation is, 1 standard deviation away, so I multiply my standard deviation by the multiplier, which turns out to be 5, And so I know this is 75. That score is 75. It sounds real simple when we have these numbers, but if my standard deviation was negative 2.33, or that doesn't work out. Let's say it was 2.33, then the multiplier would work out for your advantage. And you'll see this on your worksheet, so pay attention. So same thing, if my standard deviation is 5, and I want to know where 95% of the people lie, or 2 standard deviations, 2 times 5 is 10, so I know that is 80. Does that make sense? Whatever my standard deviation is, I multiply that by the multiplier, and then I know where I am on the rules, right? Because this is still 1, 2, 3 standard deviations. If I want to know what the high score is for 99.7% of the people, 5 times 3 gives me 15, plus the median
Mean?
is 85.
Isn't that the mean?
This is the mean.
Oh, okay, you said median.
Huh?
Mean.
Mean,
Okay.
yes. Alright, so whatever it is times the multiplier gives me. So if I multiply by 3, I know 3 standard deviations is 5 times 3 plus 15. Or 3 times 2.33 or 1.7, whatever the number is.
Okay.
And then I just add that or subtract it from the mean. If I want to look at this side, right? 5 times 1, I know that this one standard deviation is 65. 2 standard deviations is 60, and 3 in this case is 55. So it works out no matter what the value of the standard deviation is, to tell you where 1, 2, or 3 standard deviations are from the mean and what those scores are.
Okay.
My camera person doesn't look convinced, but I hope you will be following along. And we're going to do some more work with this, so like we're just getting started, all right? Okay, so over here, if you remember, I keep using the approximate. Approximately 95% of the cases lie within 2 standard deviations from the mean, right? So there's the 68% rule, the 95% rule, and I'm even going to write it here, approximate, right? And then there is the precise 95% rule.
Another rule?
Yeah, lots of rules.
Can I get a worksheet of these rules?
You will.
I'm not in your class.
Well, they're in the book.
Oh, I don't got your book.
Anyway, my camera person's taking the class from somebody else. At any rate, so before we said for the approximate 95% rule, you would multiply here as 2, right? For the precise 95% rule, your multiplier is 1.96. And this is a number you want to remember, okay? The same process, right? If my standard deviation, so let's just say the case, mean is 44, my standard deviation is 4, right? If I want to know where 95% of the cases lie, so it's not here, right? It's not 2 standard deviations away, it's 1.96 standard deviations away. So it's like in here, right? 1, 2, oh, sorry, I was wrong. See, it's in here, it's less than 2. We got it right on that side, right? So 1.96. So in this case, you take the 1.96. So my mean is 44, right? And I want to know where 95% of the people landed, what scores they fell between, and I'm going to take that 1.96 and multiply it by my standard deviation of 4, right? And I'm going to get 7.84, right? Now, I'll take this 7.84, and to get this number, I simply add this value to the mean. So 44 plus 7.84 is actually 51.84. Then on this side, to get this one, I don't add, I subtract, right? Because I'm going down, I'm going to the negative side. So 44 minus this side, I'm going to subtract, right? And so that ends up to be 3. So that's why the multipliers give you, is what are these values for spots along the line? And in this case, we're talking about the precise rules. But if you personally, right, want to know what wherever your score lands, what that means, right? And we're going to start getting into that too, okay? But for now, remember, those are the rules, right? One more time. Here we go. Last one. The 99% rule, right? So remember we have the 99.7% rule, but we also have a 99% rule. And the multiplier for the 99% rule is 2.58. And the process is the same. Just like I did here, if I want to know where 99% of the people are, they are 2.58 standard deviations from the mean. Right? So 1, 2,
Yep.
2.58, somewhere around there. Right? Somewhere right just about the middle between 2 and 3 standard deviations from the mean. Yes?
If someone wants, like say it's on a test, would you say specifically you want it approximate versus precise?
Yes, in the questions it typically say, I do have that. That information is there. That's why it's very important to read the questions carefully, right? So yes, the information in the questions, I don't do any trick questions on my exams. I really want you to know this. I've said it before, you've heard it before, because we're already into coming up on your second exam, but I'll keep saying it. There's no trick questions. There's questions that are worded so that it demonstrates you really understand the material rather than you're just regurgitating something out of the book. I don't take a statement out of the book and say, is this true and false, right? But I take a statement that's quite like what's in the book and ask you if it's true or false. And that's how you demonstrate that you're actually understanding something. All right? So, here we are. Here's all your rules. This is approximate 68, approximate 95, your 99.7, your precise 95, and your 99% rule, and the associated multipliers. I know, I tell you you're allowed one cheat sheet for your exams, but let's face it, we know you're online, you're going to basically have an open book test. I don't care. But if I was you, I would still be making a cheat sheet because you're going to have limited time for your exams and you're not going to be able to go back and reference and try to find out everything in the book. So keep your cheat sheet. I still do the recommendation. Okay? You only get class time to do the exam, which is typically 3 hours. Okay? So, and there's other things that are going to keep you occupied in the exam. All right, so there we are. There's all our rules. This is how we break up the normal curve, and we're going to be doing a lot of this here forward. So you'll get some practice, okay? And with that, we are done with Unit 2. So we're going to move on. You're going to do your worksheets. You're going to come to me with your questions, whatever it is. You'll have the exam in a couple of weeks, and then we will, I've opened up Unit 3.